Well, hello there again, friends. Today is 8/26/2022, and today's Odin Project Vlog Day 143. Um, Sorry it's been a hot minute since I've been able to upload another video. Life happens, and some health concerns came up, and some work items came up, and wasn't able to get to work on this like I wanted to. So I have completed, though, for this video, I've completed the project links list. That sets me at 58% complete with the JavaScript course, and I didn't proofread or pre-script this ahead of time. What I mean by that is I have worked this project ad nauseum a little bit each day as I had time until I was able to complete it late last night. So bear with me on some of the code as I'm trying to recall it as I go over it, since I wrote some of it pretty early on. With that said, also I want to mention, if you guys didn't see, my community posts are active now, which is super sweet. I've been waiting for them for a long time. It was actually a nice welcome. I thought you had to get to 1,000 subscribers before you could get community posts, so I'll be utilizing them. I won't spam you and overuse them, but I do plan on using them to communicate important things to you guys, as such, if I'm working on something or it's taking me a lot longer, I might put a post up just letting you know that it's going slower than expected or whatever, than my normal pace. So anyway, without further ado, let's get started here. So I'm not going to, for the brevity of the video, I'm not going to read the total introduction. So we're basically working with a linked list instead of an array. And we learned about that in the previous couple of videos and lessons here of learning linked list and the structure of them. So they talk about the structure of a linked list. This is what the structure looks like if you look at it visually. There's a couple articles to go through. Actually, it's been a while. YouTube video, article, and an archive article that go over a more thorough explanation of linked lists. So encourage you to do that. And the assignment here, real briefly, we're going to create two classes, one called linked list and one called node. I had to play with these early on. I barely remember them at this point, but I had to work with them because I don't think outside of doing the one exercise of making a class, I don't think I ever made a class. So I was using factory, but I decided to change it up and use class instead. So just for the flexibility, especially with linked lists, since we're going to be, as this says, build the following functions in your linked list class, I decided to go with the class because a factory function wouldn't have, it would have been a little more difficult to implement all these sub functions, if you will. There are 10 of them, I believe, and so it makes sense to do it inside of a class. So inside the class, I made them. You'll see they're methods. They look like functions, but they're actually methods because of the way classes work. So anyway, without further ado, let's hit the editor. So the first couple things, we're going to create the class. So here's the class called linked list, as they wanted, and it just is simply an object constructor that takes in head equals null, and this dot head will take on the value of head, and that's what starts our linked list. As you know, the first thing in a linked list is your head, and then come all the way down to the bottom here. I have another class here called node, and this is another constructor that takes in value and next, and their default status, if not fully, well, let me put it this way. When the constructor creates a node, when it's called in the code in the other methods, you'll see it'll have a value that comes in. But if there's no value applied or supplied, it will be null by default, as per the constructor method here, or constructor parameters. This dot value and this dot next take just simply the value of value and next. That was a mouthful. And so that creates the node. And remember, the node is each individual item inside of the list. So now we're going to go just down through these one by one. So here's the append. So one of the objectives was to create an append method or function, if you will, I'll just call them methods from here on out, that will take in a value and check to see, add the value, excuse me, not check, it will add the value that you supplied, appending it, meaning it's going to put it at the end, I believe. Yep, end of the list, prepend's beginning. So append will set it at the end of the very end of the linked list. So first off, we're going to do an if check to see if it's an empty node. So if this .head is not present, so if this is true, meaning there is no head, we're going to, it means we don't have a beginning of the file. We're going to create a new node by calling new node with the value and creating, and when that gets called, that's going to be applied to this .head. And then we're going to return this. Pretty simple there. That's if it's empty. If node is not empty, we're going to have tail equals this dot get tail, and this is another method that's down here, and so we'll go over that real quick. So what it does is it calls get tail. And what tail does here is adds a tail, or checks to see if there's a tail, and if there's not, it creates a tail and returns it. So here we're checking if it's an empty list. So if this isn't, if this, you'll see this a lot in the theme here. At the top, one of our base cases, if you will, is a check to see if something is there or not. So we're checking to see if the list is empty. So again, we have, if it's not this .head, we're going to return null. Otherwise, we're going to let tail equals this .head. So we're going to instantiate tail to be this .head for this moment, and then we're going to do a while loop, and so we're going to iterate through tail.next. As long as tail.next is not null, meaning there's something in the tail, we're going to take that same value of tail.next and apply it to tail. And then we're going to keep looping until that does become null, and that just simply tells us that we're at the end of our list, and we're going to return tail. And then tail will come up here, and then tail will become tail. Remember, these are inside their own methods, so they're local functions, so or local variables, so you can do that. Maybe not, super advised, but as far as readability and best practices. Sorry, been a long day. Best practices and best coding techniques with dry method. Probably not a good idea to use the same name for your variable, but this, just for this assignment, this is what we'll do. And so then we have tail.next takes on new node value. So here for the append, we're going to call a new node value. So basically, we're going to append that that value by creating that new node and applying it to tail.next, and then we're going to return tail. So, which will be that new node value we just applied. And that returns tail back through append, and you get the result. So I won't show you the result. It's too much back and forth, and it'll make the video really long. So I'm going to go through all the methods first, and then I'll show you the console.logs and how it played out at the end. And I did run, I didn't say to do this in the example, but in my code here, you'll see I did run it in the terminal. So I'm running the package file for what they call that. It's been forever ago now. Where you create the package file that runs the node monitor. So I'm running node monitor basically, so I can run it so I can run my console logs in the file inside of the terminal. So here we have prepend, and this is the same concept. We're going to bring in value. We're going to check if it's empty node. So again, if this .head is not there, we're going to instantiate new node value and apply that to this .head and return this. Same as up here. And then otherwise, if there is a head already, we're going to take the head and we're going to apply it to previous head so we can move it. That's just for the sake of moving things around, because in the next line of code here, we're creating a new node and passing in the property of value and previous head. So previous head will be basically what it sounds like, the previous head value that was in our in our linked list, and the value that we passed in from the parameter. Excuse me. And then that becomes this dot head, and that'll be that. We already went through getTail. That's just getting the tail or setting the tail. Got a frog in my throat. Excuse me. Let me take a drink of water real quick. Sorry about that. All right. So we have size here. We're going to let node count equal 0 to set that local variable and give it a value of 0. Let counter equal this dot head. So this dot head is going to become counter. And we have a while loop here. So we're going to do a kind of like up here the other while loops. So we're going to have a counter. As long as counter is not null, so long as this dot head is not null, we're going to increment node count by 1, and we're going to apply counter.next to equal counter. And what that's going to do is it's going to keep incrementing our this basically exists to increment the counter so that we can count the size of the and the number of items or nodes in our list, and the node count plus will be our our node counter itself. Think of it as kind of like indexing. Since we can't index, since the indexing doesn't really exist on a list, so we have to do it this way. So when we return the node count, simply return that, and that returns the total size because, like I said, we're incrementing this by 1 every single time we loop through iteratively, whatever, cannot say that word. So there's that. So get head, we're simply going to return this dot head, and that's how we get the head on that. Real simple there. And then I have at, and what at does, I can't remember at. What's at? At returns the node at the given index. Okay. So the at is so you're supplying the index value you want to look up. So again, we're going to check to see if it's an empty list. So if the head isn't there, we're going to return null, and we're going to exit out. Otherwise, we're going to let counter equal this dot head like last time. And then we're going to create a for loop. Let I equal 0. I is less than index. Increment I by 1. And then inside that, we're going to do the counter.next equals counter and apply to counter, just like we did up here in the while loop. And then in this one, we're going to return a fancy-dancy if statement. So basically, return counter if counter is available. Otherwise, we're going to return null. Return null. Sorry, my Tourette's is active too. So if the counter is null, meaning it's not there, we're going to, or not counter is null. You get my point. It's an if-then-else statement. Or it's basically a if-then-else here wrapped into a return statement. So it's going to return counter if counter is available. If counter is null or not available, we're going to return null. So I have pop here, and what this does, I believe, is removes the last element from the list. So I'll make sure I'm saying this right. So this is going to remove the last item from the list. So here we're going to check for empty list again, same thing. And then for one node lists, we want to do a check here. So if this if it's not this dot head dot next, we're going to take this dot head and give it the value of null and return out. This means that pop won't work because the linked list only has one node in it. So there's nothing. Well, you pop that and there's nothing to return, so you will return null. And then otherwise, if there's more than one node, we're going to let pointer before tail equals this dot at dot size this dot size minus 2. And so essentially what this does is this looks at the size. It's called size that we talked about earlier up here. So it's going to call size. It's going to get that value, and then we're going to minus 2. And minus 2 is there because we want it to look at the pointer before the tail. So if you know the tail is going to, if you do minus 1, you would get the very last item. I keep saying item. The very last node in the list. If you do minus 2, it'll do the one to the left of that most recent. So that's why we do that. That's why that math's like that. And then the at is the method from above also. So here we're calling at, and we're returning that counter, and then that's going to become the value of pointer before tail. So then you have the pointer before tail.next equals null, and that's because we need to manually instantiate that as null because we just popped it out. So if you remember, the end of every, I believe the end of every linked list needs to be null, if I remember right. So that's why we set it as null and return this dot head. And so that's going to return not the null, but it's going to return what we popped out, because the instructions say that pop removes the last element from the list. So returning this dot head will return the first item in the list. Now I think about it, it really doesn't matter, I suppose. Again, see, I've done some of this quite a while ago, so I'm trying to remember. Yeah, anyway, I keep moving on here. Then I have contains. Contains here is has a value, and then here we're going to check again for the empty list, and here we're going to set the counter to this dot head. So we're instantiating the counter with the first, the head of the first item or the first node in the list. And then while counter is not null, so again, kind of like that other while loop we had, we're going to have, but we have an embedded if statement inside this while. So I'm going to do a check for if value equals strict equals counter.value. So if the value that the contains, sorry I didn't mention that, the contains does the returns a value true if passed in value is in the list, and otherwise returns false. So we're going to look to see if value is in there. So if value is in there, if the value that we supplied is in the counter.value, which is in any one .value in any one of the list nodes, we're going to return true. Otherwise, we're going to increase the counter with the next item, which is counter.next, as we've seen before. Recurring theme there. Otherwise, we're gonna keep looping through that, and then when that becomes null, we're going to break out of the loop. And if we have no if statement that has triggered, we're going to return false. So that's how that works. And then find is similar. So we're check here. We're going to create an index that equals 0 to instantiate it. We're going to instantiate a counter to equal this dot head again to get that counter started. So again, we're going to do another while statement doing the same thing. Counter is not null. We're going to index through. We're going to loop through or iterate through with index incrementing by 1 because we want to count, because in find we're doing a returning the index of the node containing value or null if not found. So so we're going to do another challenge here, an if challenge. So if the value equals counter.value, just like I had up in the contains method, we're going to return the index. So that means that the value was found, and we're returning the index because in this particular one, we want to find the index of the node. So we're not seeking the node value, we're seeking the node index, which doesn't exist as I mentioned earlier, but we're prepending it here via this while loop. And if that's not triggered, we're going to do the counter.next. And then if it gets all the way through and if the if statement does not produce any result, we're going to return null. Just as it said, because it said here we're going to do null if not found. Okay. So then we have the last one here, toString. I know it's a long video. Thanks for holding up with me, guys. Hanging in there. So we have we're going to check again for the empty list, and then we're going to turn null in quotes. This one's a little more to chew on here, but I'll just, for the brevity of the video, I'll kind of speed through it a little bit. So this one is a little more complicated. So we have let output equals blank string, and we're going to have a counter that takes on this dot head as usual to get our counter going. So we're going to do another while loop while counter.next is not null. Same loop as we've been using for a while, and we're going to have an output equals we're going to use temp template literals. Make sure I'm saying that right. Yeah, template literals. We use template literals here to assign the output. So this is going to pull down the output from, think of it as kind of like an increment. So the first time through, it's going to be, it's just, they're always string, but it's going to be nothing. Well, this output will be nothing. It will become that after the first iteration. But anyway, so this is going to seek out the output. So the toString, I forgot to tell you, represents the linked list objects as strings, so you can print them out and preview them in the console. And this is the format that they want to see. And so this is the template literal use, and then we're also going to use counter.value because we also need to retrieve the value of the number or the number of the node that in this example. And then this is just some beauty sugar tax that we need to put in here for it to look like the way they want it to in the requirements. And then counter equals counter.next, just like we've been using to increase the counter to the next node. And then we're going to keep can't say that right. We're going to keep using template literals, and then on that, and keep looping through, and then it's going to return out the template literal output and counter.value, and then adds in that null sugar syntax there. So this is gonna again does the same thing, counter.value, and so what you end up getting at the end. So here's all the console logs. So basically, I have one for prepend, so we're going to add one to the beginning or end of the list, or excuse me, beginning. Prepend's beginning. We're going to add 1 to the beginning. We're going to append 2 to the end, 3 to the end, 4 to the end. We're going to check the size. We're going to get the head, get the tail, and then we're going to what was add again? I don't remember. We're going to turn the node. So we're going to return, we want to see what node is at index position 2. We're going to pop out the last node in the list. We're going to find out what's contained at position 3, I believe that one is. Turns truth value passes in, just true or false. So we're gonna find out if anything exists in index 3. We're going to find an item in 2. Find index returns the index of the node containing the value of node not found. Okay, and then toString is what I just was going over. We're going to print out the current available linked list in a string format. So this is what it looks like in the terminal. So if I go up here, scroll this down. Sorry, this video is becoming overly long, but I knew it was going to be. Thanks for hanging out. We're almost there. So prepend 1. So here's all the console logging. So as you would expect, here's the prepend. Here's the append. Here's the second append. Here's the third append. Here's the size, so we're just getting the running the method for the size of the linked list. So it's 4, 1, 2, 3, 4, as you can see there. And then the next one, we're going to get head. So this one is going to return this right here, and this is getting and retrieving the head of the list, which is value 1, and then it has the next node in value 2, next node 3. But first one is 1 since it is verified from up here. Next thing we're doing here is we're going to get tail, and we're going to get tail right here. Get tail's value 4 since it's the last node in the list. Next one we're going to do the so we're going to retrieve whatever's at position 2, which in this case we incrementing from 0, I believe, 1, 2 will, or no, it starts at 1, 1, 2, am I right on that? Oops, what am I doing here? Yeah, Yeah, it starts at 0. So it'll be 0, 1, 2. So it's going to return the value of 2. And make sure where I was at there. Sorry, it's a lot of code here. I'm kind of getting myself confused. All right, so then we have pop. So this is going to remove the last one. So it's going to remove number 4 from the list, and I don't think it returns out anything. It just pops it out. And then we have contains. So we're going to go to whatever position 3 is, and we're going to say, is it true? I think is this the true false one? Contains, I think it is. Yep. So we're at true false here. So so right here we're true because we're going to look at 3, and 3 is in the current list right there. And we're going to do find, and we're going to find 2 is in there as 2, number index. Kind of confusing when you use your values are numbers and so are your index, so it's kind of confusing. But then we have our last one, toString here, and that does this right here. So I'll pretties it out, 1, 2, and 3, which is, after all this is said and done, we have 1, 2, and 3 left, and then of course we append null at the end to end our list, our linked list. So yeah, so that went long, but I hope you had a good understanding of that and it flowed well for you. Please feel free to watch it again and slow me down if you need to or whatever. I kind of went over that fast, especially the toString one. That was a doozy for me. That one was what I was working on last night. So anyway, thanks for coming along the journey with me today. I hope you learned something and had a little fun along the way. Please like, share, and subscribe, and share with others, and let them know about the channel and have them come check it out. And like, share, and subscribe for more content, and let me know in the comments section how you guys are doing with this linked list project and how you're coming along with it. And I didn't do the extra credit. I just wanted to keep moving on with the project here. So if you guys do that, let me know in the comments as well. So with all that said, till next time, see ya.